Thank you very much for the invitation, and hi there, everyone. Yes, so I'm Dave Wallom. Gaining insights on domestic and non-domestic energy utilisation through informatics, or how I link radio telescopes with energy theft. Because my aim here today is actually to tell a bit of a story. It's to move from how we started doing some work looking at radio telescopes, how you actually, how you organise information for those, and how we then link that into smarting energy networks, and that's particularly at the distribution level. And as part of that then, how that linked into understanding drivers of energy consumption through analytics, and then from that looking at energy in a particular sector, in this case retail, but also then energy theft. And from that point of view, so telescopes to theft, T to T as it were. So the radio telescope that I'm going to talk about very, very briefly is the Square Kilometre Array, which some of you may have heard about. It's the world's largest, going to be the world's largest science experiment covering thousands of kilometres and is going to generate exabytes of data. The really important part of it, though, is it's going to be run by the radio astronomy community, and they have a few fairly fundamental requirements. From their point of view, what they want to be able to do is plug algorithms and applications that they develop into a common framework which interacts with the radio telescope, because they're not IT people, they're astronomers. And so from their point of view, they want to be able to have a common framework which their applications can interact with, that controls the connection with data, that runs in the most appropriate manner on the computational resources as efficiently as possible. And as part of that, we developed this thing called the Pelican Pipeline. This was for the design study. This was around how we were going to get access to or prove that we'd be able to build a £600 million telescope and it would actually do what it was supposed to do. But the point of the e-research centre that Bob mentioned earlier that I'm part of is actually a particularly fundamental one. Our point is that we work with the research community, we build a tool or service, we look at the application design model of whatever it is that we're working with, and then we step back and we say which other communities actually have a problem that is shaped like this. So which community, if you were to ask them, has a problem that's very similar to this, where they want to be able to plug applications into a known framework and not have to worry about fundamental interactions with the underlying IT system. And the really interesting one that we came up with almost immediately was, of course, that we go from astrophysics, which wants uniform APIs for application designers, uniform functions for handling fundamental I/O, and they want to provide controlled interactions with the scheduling system, the compute platform. And what we found actually was that the distribution network operators are also getting to this point. For those of you, I'm sure there are many in this room that understand this just as much as I do. The distribution network, of course, is the last non-real smart part of the network. And though some of the DNOs would be very upset when you say their network isn't smart, it's certainly not instrumented and it's not analysed to anywhere near the level that the transmission network is. The transmission network has a lot of applications. If you go to the National Grid Control Centre, they're very proud to show you all of the different services that they're able to show and understand exactly what's happening in the transmission network. So as part of a European Community Framework 7 project, High Performance Computing Technologies for Smart Distribution Network Operation, we took the framework that we designed for astrophysics towards a couple of distribution network operators from Europe, so EDF and Gas Union Fenosa. And the point here was to say that the network that we're going to need to get to within distribution is going to have to be able to support plugging in of tools and services that have been designed elsewhere that maybe are commercial products, so they're not going to be able to be something that the DNO is going to be able to look into themselves. They're going to be black box solutions, but they're going to want to run them all in a coherent way, connecting to the distribution management service that they actually operate. So of course, the big motivation is that, of course, here is our traditional system. It's a very sort of generator to consumer type system, and we want to get to smart grids where everyone is connected and information is flowing. But of course, what we don't want to do is we don't want to turn off the lights on the way, because that's always embarrassing and my mum would be really upset. From that point of view, what we've got to do is we've got to smarten the systems essentially in a way that is gradual and able to ensure that we keep everything running. So what we want to be able to do is take current distribution management and add smart technology to it without any interruption of supply, shall we say. So what we came up with, and utilising almost the technology from the astrophysics experiment, was the idea of application wrapping in a computation as a service environment. And from that point of view, it was about the fact that different applications have different computational requirements. They have different precedent levels. They need to be run by different communities with different levels of urgency, shall we say. And from that point of view, that needs to be controlled by the distribution network operator, by the guy in the control room. He doesn't need to know everything about this, but what he does need to know is that when there is an incident in the network and he requests a system state estimation and a restoration algorithm to run, it's going to run right there and then, because of course customer minutes lost means money as far as the distribution network operator is concerned. So from their point of view, smarter distribution was really around 4 different key services. It was around a constantly available distribution system state estimation using available information that was within the system. It was about the idea of service restoration algorithms being able to be run and preempt other services within the computational system. It was about condition monitoring and analytics of the network service. So could you actually tell the condition of various network infrastructure using the various different streams of information that you had? And of course, voltage control, and that was particularly the case within areas of networks with high amounts of distributed generation. And the idea was essentially that all of these would operate as individual black box services within the high performance compute engine and storage operated by the distribution management system. So at that point, it was the idea that we could plug all these in and we could create a smarter distribution network without turning the lights off and have the ability to add new and better services as and when they came online. But the most important part in some ways is about this reuse idea. The energy distribution guys, as part of that, we developed computation as a service. With the condition monitoring, we talked about developing computational services to support data mining and machine learning for condition monitoring. And then we talked about having new methods to handle uncertain data. And from that point of view, that comes, that's a really important thing to remember, is many algorithms for machine learning that were available, certainly as this project was on the go, really relied on having really very good ideas of the boundary of the quality of the data that you're actually going to use. Now, from the point of view of the energy network and very large rollouts of IT infrastructure, so for example, smart meter rollouts, when you're talking about tens of millions, you're not going to be able to guarantee how well every single one is behaving. And from that point of view, you want to be able to do certain types of machine learning and algorithmic services knowing that you can handle the uncertainty in the information that you're going to generate. So following on from that, we then went into our next activity, which was the Adept Project, which was an EPSRC activity in collaboration with Brunel. And this was looking much more at the domestic area. And the idea here was three key things. The first one, and this is looking at tariffs and pricing, is thinking about how are consumers really ready, willing and able to understand dynamic tariffs or complex time of use tariffs. So who can remember when mobile phones were introduced? So can you remember peak time and off-peak time in your mobile phone? So when you then got past simple peak and off-peak, how many different types of peak time were there? Because the really interesting one, at the very height for mobile phones, there were 180 different tariffs, pretty much from Vodafone. And you can tell immediately what happened there. Everyone ignored it and they just used their phone, which is why most people now have a flat use. You pay for your phone and that's it. And that's the thing, of course, that you want to avoid if you're introducing dynamic pricing and time of use pricing within smart metering, that you essentially confuse people like my mother, that to such an extent that she says, well, I don't really care, it's only 20p, so I'm going to ignore putting on the tumble dryer at this time because it doesn't matter to me. From that point of view, how that's going to be a failure in some ways of the introduction of these tariffs, and certainly of all of the infrastructure that we've just spent a lot of money, time and energy, ironically enough, of course, to introduce smart metering. The other one then that we're looking at is investigating the relationship between dynamic energy tariffs and power and networks. So a large amount of simulation and modelling. And then also, can we design a computational platform that would handle all of these data flows? And from that point of view, make sure that not only are we getting consumption information, but we're thinking about other streams of data as well. And from the point of view of the data that flows within this activity, and in some ways within a smart meter network, you can see this was the sort of idea or diagram that we had. We had our friend, the customer, over here. We had their 3G, 4G, or 5G, of course, now. This tells you how old this project was. Yeah, this 5G isn't there. Which interacts with either their house or the office, depending on what it is. Interacts with the distribution infrastructures. It has this idea of a common communication system, the DCC, for example. But also it then has this idea of this high-performance computing environment, which we took from the previous project from HyperDNO, to say actually that what we've got to be looking at is analytics and data mining to look at the pricing and tariffs that are available, which support the idea of what decisions people are going to make around utilisation. So from that point of view, if we start introducing very extreme tariffs, what is it actually going to do in terms of how much people will follow it? And from that point of view, really also, can we say to people that if we do introduce real-time pricing, you're going to be a winner? Because from that point of view, if you're going to introduce any sort of tariff change and stuff like that, and you turn around to people and you're guaranteed to pay 50 pence a day more, they're probably not going to like it and they're probably not going to want to adopt it. So from that point of view, this was very much around what can we find out from the information. From the point of view of data mining, then really, it's around categorizing and classifying costs. And we had very luckily, fairly new at that time, a data set available to us. The DEHEMS project, which was an ECFP7 activity, had a whole host, about 250 properties in the UK and Bulgaria that had smart meters installed on them to provide domestic load information. Now, the really interesting part about that, and this is on the right-hand side, is this is the number of customers that have availability for number of concurrent days across the full period within that data set, which tells you something immediately. So here we go. So this is from 0 up to 220 fully consecutive days of data. across about 200 customers within that data set. And the scary thing, because these weren't shonky, these weren't cheap smart meters. These were state-of-the-art smart meters in 2009, 2010. There's a really worrying fact of quite how few. You're not talking about a lot of data up at this end. So from that point of view, you're already talking about data sets that have holes, that have uncertainty in them right from the very start. Now, of course, one of the things that we were going to do looking at this data was do a load of clustering. And from that point of view, we were going to use two different types of clustering. The first was k-means, which is a fairly well understood clustering technique. But then we also wanted to look at something a bit more innovative. And the postdoc that was working with me on this was actually a language specialist. Was a computational linguistics specialist who'd done a lot of work with Bayesian clustering models and brought with him this idea of this mixture model, the Dirichlet process mixture model. And from that point of view, that has a very, very interesting possibility. K-means, when you want to use it, of course, you have to tell it how many clusters you want to make, which basically says right from the beginning, I know that my data needs to be split up into X number of groups or chunks. Now that's which can be okay if you have some insight into what is the underlying driver of that. Now, the reality in this is that we didn't want to do that, and one of the advantages with DPMM is actually that it's driven by what's known as a concentration parameter, which basically means that the data itself tells you, because you adjust this concentration parameter till it essentially becomes constant, that the data itself tells you how many clusters it contains, which allows you to then say, okay, well, from that point of view, I'm going to say that we're going to look at these properties from the UK and Bulgaria, and we're going to say, well, okay, well, how many different groups does the clustering actually find? From that point of view, are there different types of population within there? And it's not necessarily whether they're in UK or Bulgaria or whether they're flats or houses or whatever, but I'm actually allowing the clustering itself to come up with this. On top of this, from the point of view, and this was a real extension of the project, was we also managed to get a handle on a load of commercial data from a local energy aggregation company called Opus Energy, who are based just up the road from me in Oxford. And from that, it was looking at, well, this was the idea of how we measure the benefit of switching switching tariffs. So this was the result of the clustering within using DPMM of our domestic or residential data. And it came out every time consistently with 4 different clusters. And the more, from that point of view, they look very sort of raggedy when you look at them just implanted on top of each other. And we'll come back to these guys later because they're really interesting, because bearing in mind it's domestic. But this is the plot of the centroid. This is the low profile of the centroid for each of the clusters. And the interesting part here is you can see very clearly, well, here's our fairly standard domestic load curve. We've got some users that are pretty large evening customers. We've got these ones that are pretty flat off. And then we've got these guys that give a very, very different curve, which now, having operated in a different area, I recognize immediately, and some of you obviously will as well. But what we were able to say was, well, okay, from that point of view, the consistent point around this was no matter how much we adjusted the clustering on this, that these clusters came out pretty much every time. And we then started to look at, well, what does that actually mean if we were trying to do demand management and things like that? What would that mean for elasticity? And that allowed us to then, through the work of Sarah Darby within the project, to run a couple of focus groups with the different communities to talk about how they would react to some of the points on different tariffs. From the point of view of performance of the clustering, we basically saw that DPMM, and this is a couple of fairly standard clustering measures. We have the variance ratio and the scatter index, and we can see that DPMM works basically almost as well as any of the other standard clustering techniques, right up to a fairly large number of clusters. So we were fairly pleased with that. So from that point of view, it meant that at the end of the day that this was a technique that would have value when attached or utilised with domestic load consumption data, and could be then used as input into a number of other activities. From the other thing that we looked at, and this is something that of course there's been a lot of discussion about. So the DEHEMS dataset came with a 6-second resolution. So it was a pretty big dataset. And of course, it's very, very dissimilar to what we're likely to get from any smart meter rollout, from any, or certainly that people are utilising in smart meters on a large scale at the moment. So what we did was we created a number of different sets of data by aggregating our 6-second data. So we made a 1 minute, 4 minute, 15 minute, 30 minute, 60 minute, and 120 minute resolution sets of data, and then looked at the different sets of measures of cluster performance that you can get for each of those. And the interesting part, so from this you would say, so looking at the different time series, we can see here that basically, interestingly enough, there's very little variance until you're getting up to large numbers of clusters. And then from that point of view, the green is the 1 minute, and the 100 is, so the green is the 240 minutes, and the red is the 0.5. And you can see within this parameter, there's very little difference, interestingly enough. From the concentration parameter and the number of clusters here, there is a wide amount of difference. And the points of this is basically at the end of the day, when you look at this, that anything over 4-minute resolution becomes very difficult to pick out the same number of clusters in the information that you have previously. So the clusters start to essentially disaggregate themselves that we'd seen previously within the very high resolution information. And from that point of view, an important point, if you're then going to use this data for other activities, means that the resolution of the data is going to impact very greatly if you're going to use this data to try and do classification and things like that. So the next part, and this is around real-time pricing. This is the, can we actually assess the impact of the introduction of real-time pricing? We had 12,000 UK businesses data. And from that point of view, the major thing here was we ended up keeping them in their major sectors, even though they were actually subdivided. And the main reason, of course, if you're subdividing into 44 from 12,000 businesses, you do end up with some sectors that basically have very little in them, and they become very difficult to work with. So these were the tariffs that we essentially used. So we've got, of course, our fixed price tariff here. We've got a fairly standard time of use tariff that we got from Northern Ireland Electricity. And then we've got the real-time tariff, which was actually based on the wholesale price of energy, on an average wholesale price of energy for a same period. And the 5 different major areas that we're working with, so we had the entertainment sector, industrial sector, retail, social, and other. We had lots of people that we were collaborating with wanting to investigate the social, because basically that was pubs, clubs, and restaurants. Not many people wanted to go and investigate the industrial sectors. But the important point here is that this is the normalized daily power demand profiles for each of them. And first of all, of course, does anyone remember seeing that was the cluster 3, the retail guys? Yes. But you can see here there are great differences. There's, here's entertainment. From that point of view. So there's a lot of difference. But the point is here, if you were to apply each of these profiles to each of these different tariffs, actually, and bearing in mind that these are the centroids and there are variants within those clusters, actually who benefits, who wins and who loses from the migration from one tariff type to another. So, just as an example here, what we looked at, so from this is looking at the transition from fixed price to real-time price. And we can see the interesting point, and we've just picked out on the top one, two different groups here. So the entertainment sector and the retail sector. And we've highlighted the centroids of all of those that are winners and all of those that are losers within those groups. So from that point of view, so obviously a winner is someone whose bill effectively decreases when they make the transition from one tariff type to another. The loser is obviously the opposite way. And what you'll see, of course, if we pick the black here, well, so the winners, you know, they've lowered their centre of the day. The entertainment winners, they've increased their out of prime, their peak, their utilisation here, and they've decreased their utilisation here. And we've seen essentially those that have a much more balanced lunchtime and evening load actually are those that are the losers from this point of view. But the interesting and important point to take here is more the fact that actually there is in some cases very, very little difference. So from a price elasticity, from a behavioural elasticity point of view, if you're able to change your behaviour within the entertainment sector to work out, well, okay, if I start thinking about how I'm using energy in the morning, how I'm utilising energy at lunchtime, basically, very small numbers of transitions, very small differences. Of course, as we see on the graph on the left-hand side here, we've got, so the solid line is the transition from fixed price tariff to real-time tariff, and the dotted with the circles is from the time of use to the real-time tariff. And what we look at here is where you look at mean total consumption for the particular business and the percentage of winners averaged over the whole data set, that actually the larger the consumption, the more winners, essentially. Now that's an interesting point, and that's across all of the different sectors that we're working with. So that's averaged across the whole data set. But what it actually shows is that, there's a lot of spikiness in terms of, the different sectors will be contributing at different points in this curve. And there are some very seriously large users within this area up at this end, mostly coming from the industrial sector. But the interesting point, and this was something that we went back to the colleagues at Opus Energy for, is that, of course, having this information allows you to effectively think about a new business. It allows you to say, well, okay, I would be able, with my knowledge of what are the ways that you want to be shaping your energy consumption to do better or work better, essentially, when making one of these tariff transitions, I would be able to go to a consuming business that they're already working with from aggregation and say, right, we're thinking that actually, if you were to make this transition from this particular tariff to this particular tariff, then we can show that you're actually going to do better. So from that point of view, this is around saying that, okay, this is a new service that people like energy aggregation companies and retailers can be thinking about, and to have it backed up by strong analytics that actually validate this as it's being done. So, from our point of view of our linkage, we had our energy system data there, our machine learning and analytics, where we're gaining understanding of drivers of energy consumption within domestic and commercial customers. Following on from that was a project that had a fantastic title of Working with Infrastructure, Creation of Knowledge, Energy Strategy Development. I have to thank Katie Yander in the Environmental Change Institute for this one. Or WICKED, which was looking at energy utilisation within the retail sector. And we did manage to get, and from that point of view, we managed to get a very substantial number of commercial partners within this. Now, WICKED, this is an idea that effectively energy consumption and energy utilisation is a problem that's multifaceted, interconnected, and one that has no simple solutions. From the community that we're working with, of course, we have multiple different communities that are actually participating. We have people like we have the B&Qs, we have the John Lewises. We have right the way down to the small corner shop that's within everyone's street. They're still retailers. They're still essentially the same group and very much dealt with in some ways very much the similar way by industrial strategies and regulation and from that point of view. So what we were trying to say is, well, okay, there are these three different communities. So the top down, the analytics of the data rich, and these are the guys, these are the guys like the B&Q, the Argos, the Sainsbury's, the M&S. All of these guys are working with energy managers. There might be only one energy manager per group, but if they're lucky, there may be more than that. But these guys have access to data, and very often have access to data on a very regular basis. So from that point of view, there's a lot of capacity there for learning from working with them to increase their understanding of their own data. Right the way down to the guys right at the bottom who have no data, because they're the guys that are renting their shop from a landlord. They don't have access to the meter. They have no understanding of what energy they're consuming, and they have no understanding of how their business practice connects with their energy consumption and utilisation. And from that point of view, that was the group within ECI that were thinking about how you actually create a smart meter for them that doesn't cost them the earth, but actually is something that they can get for under £10. And actually, Russ Laborie in ECI has basically built a smart meter that you can get for under £10 that you can just hook up to your system. The data rich. Now, these are the guys, they really do know what they're doing. They have people on board who are the staff that are engaged in this. But interestingly enough, one of the bits that we also found with them is, of course, these guys are still retailers. These are people that are, the bottom line is how much product do you get out of the door. And what that really means is it talks about return on investment times and things like that. We found at least one major national chain that has to have 100% return on investment on any energy efficiency work that is done in 1 year. So basically, there was a man, and it was a gentleman in this case, the energy manager in that chain, who was feeling very under pressure whenever anybody talked about whether or not he was going to pay back the money that it cost to do X, Y, or Z. There was a lot of LED lighting went on, and that was sort of the way there. But one of the things we wanted to look at, and this was a large electronics retailer, was from that point of view, what can we get from very simply from the information that he has access to on a day-to-day basis? Can we say, well, okay, what can we do to help him out? The interesting thing, of course, is he has 30-minute electricity readings, because that's what every smart meter-y type thing has at the moment. But he had very little metadata that went with it. From that point of view, he certainly had, he had the postcode of the shop. He was able to get us very easily. He had very little knowledge within the company of how he would get any information on what the type of building was that the premise that the shop was actually located in, or anything like that. But one of the things we were able to do almost immediately was identify meter problems. So we found basically that about 3% of his meters were broken and just giving constant values. And not the really interesting part here, of course, we're not talking about constant maximal or minimal values. We're talking about constant values that can be in a use of, would be in a sort of expected range of consumption. which becomes very tricky then to say to any other type of system, unless you're specifically looking for it, oh, well, if you're seeing consumption of this, then that's a bad place. We had quite a few off, well, about 1%, and 0.3% of the meters were intermittent failures. So they give you really good data for a long time, and then they give you real rubbish for a very short period as well. So, from that point of view, there's a non-trivial number of meters that actually needed attention. And that was a value add as far as he was concerned that we immediately came to, because he could go back to, in many cases, the landlords of the premises that he was based in and say, guys, you own the meters. I want you to sort this out. So that was the first step. The next one, of course, is what sort of effects do large energy efficiency projects have? And this was a very easy thing that we were able to work with another retailer to actually look at the same population of shops and say, well, okay, over the years that we've been looking at energy, are you seeing a constant decrease and actually benefits from energy efficiency projects that you're working with? Then, how do the different stores that you're working with contribute to the energy consumption of your portfolio as a whole? So here we can see we have a particular retailer that has food shops, high street or what they call high street or premier shops, and then their outlet stores. And from that point of view, we can see very clear groupings of the different types of energy consumption when it comes to the ratio of peak to off-peak consumption. So from that point of view, when they're open as they're retailers, because of course they have store opening hours, that's quite handy in many cases, the ratio of store open to store closed effectively. Also, where do they sit in terms of the total consumption from the different types of stores in terms of quartiles of consumption when comparing the floor area of different types of sales to the different types of store? But the really interesting part, and this was something that the managers were really getting into, was this idea of, well, where are my best stores? Where are my worst stores? How do I understand where best practice is? Because in some ways, many of these stores do operate with a level of autonomy. So from that point of view, where do you concentrate investment? So, these stores up here, are doing very badly. So I want to go in there as this group energy manager and say, actually, what's particularly bad about these? Have you guys got some sort of problem or issue that we need to work with your landlord on to really solve? And of course, where do I want to go and send all the other guys from all the other shops to go and learn from these guys, because they really know what they're talking about? The other parts of this, and this was a specific part of the activity within the project, was working with the law department around the idea of environmentally friendly legal instruments. And so this is the idea of green leases or memorandums of understanding, which establish a partnership between the landlord and tenant. And really what we wanted to say was, were they worth the legal fees that it takes to actually establish them? Because, of course, it's legal fees, so they're vast. And from that point of view, we really wanted to look at, could we see a quantitative benefit to the establishment of these? And I must admit we struggled. And the reason we struggled was really two things. The first one was that, we had energy consumption information, we had metadata in the floor area and postcode, but even the group themselves didn't really know when exactly these particular legal instruments came into force. So what they said to us, well, so say they're all after March 2013, and so we had to deal with that being the day. Now, but the other problem with this, of course, is all these instruments do is say, well, okay, what we're going to do is say, we will work together. It doesn't mean the day they're signed, you're going to rip out the heating system and suddenly install a new and energy efficient one. It says that we've agreed we're going to do something, we're going to work together in future in a close and collaborative way. So we looked at a bit of self-comparison, and this was looking before and after. And you can see here that there are a significant percentage of stores that have the consumption after lease is smaller than the consumption before lease, but unfortunately it's not really statistically significant. But it's there, and one of the things from the point of view of interacting with the legal teams was actually that came out with, actually that's that's still important for us to know. That there is something, even if it's not statistically significant, it's something we can start having conversations with people about. So I'm going to quickly tip on a bit because I think I've been told that I've got not much longer to go.
We'll take some questions.
Yeah. And what I'm going to do is I'm going to say, well, okay, so from this point of view, we linked consumption and non-consumption time series providing analytics. We've linked consumption to business process within Wicked. Now, of course, data mining, data mashing, we're now into, of course, going back to our previous slide here. We're going back to these guys here. And it just so happened that on one of the days when I was putting together a presentation on this project, that the BBC had an excellent story about people, criminal gangs, hot wire power supplies to help cut bills. And I thought, ooh, that's quite interesting. And it turns out for 50 quid, if you go on the dark web, for 50 quid, someone will come along and fix your meter. And I thought, oh, that's quite interesting. So I went to go and talk, and British Gas came to talk to us. And we ended up getting a project on them, Data Insights Against Energy Theft. And at that point, before we'd started having that conversation, I thought, well, that's interesting. So British Gas had 250,000 smart meters that they currently run. And they have 250,000 smart meters in the commercial space. And I thought, well, I can't imagine there's that much theft goes on. So energy theft, it costs the UK about 400 million a year. Which means that you're paying an extra between £7 and £20 a year on your energy bill, and that's every single one of you, because of it. The interesting part, of course, is it's very often accompanied by other criminal enterprise. We've all seen the infrared of very hot buildings, shall we say. But more importantly, basically an awful lot of it involves meter tampering. And that is a health and safety hazard, and it can, look at this. Who on earth thought that was a good idea? Now, that can be lethal. And the really interesting part, though, is at the moment, meter theft requires somebody to go and see the building. It requires somebody to go and visit. They have the Revenue Protection Unit within British Gas, who claim to be one of the only retailers that are really, really getting heavily into this. Have a very large team of people, inspectors, who will go and visit properties. And they have a lot. And so when we started this project, we went to the first kick-off meeting and I said, well, have you got some cases of energy theft? And that was after they told me that they were dealing in the commercial space, and I was being really naive, and I thought, well, that'd be one or two. And he went, yeah, here's a spreadsheet of 200 from the last 2 years. I was like, okay, quite a bit then. So, from that point of view, it's like, well, how do we think about doing this? How can we actually think about utilising data generated by the meters to actually think about identifying energy theft? Now, the interesting part, of course, is there have been an awful lot of projects thinking about how you look at consumption data to identify theft, losses, whatever. So, from the point of view, of what the data that we had their portfolio of meters. In the end, it ended up that we were allowed to basically get all of their commercial smart meter data, which was quite interesting, and did highlight a couple of interesting problems in data collection. We wanted to make sure, of course, that data was regularly arriving and had fairly high quality, which meant, of course, that we had to do actually a lot of cleaning. We had to do a lot of going back and talking to the people that are actually providing the data Because the other thing here is the meter operator is very often not the retailer. And they will be relying on, and I'd never realised this, so within our project we had EDMI, the smart meter manufacturer, who operated the head-end system which communicates with all of the EDMI meters that are out there at the moment. We had G4S, who became Morrison Data Services, who are the meter operators for British Gas, who interact with the head-end system from EDMI, who then pass the consumption data on to British Gas. So you've already got 3 actors in a data chain. Now the other part here is, and the innovative part I would say with this project is, we weren't obviously just looking at consumption data. Smart meters actually generate a whole load of event data as logging information that is basically completely and utterly ignored as it stands at the moment. There's been an awful lot of work on standardization of consumption information between all of the different smart meter manufacturers. There's basically been no work on standardization of non-consumption data streams that these smart meters generate. So the system that we've ended up building has involved the meter system, which essentially is the EDMI head-end system, pushing data, and that's 2 streams of information, consumption and non-consumption, into a very large MongoDB service that is then runs a whole load of analytics, which I'll tell you about in a moment, to essentially give you a list of meter points which have a higher indicator of anomaly. The data that we get, and we're doing this in a slightly different way. So we're taking from the consumption information, we're taking average daily data. So we're not going into all of the individual load profiles, we're just doing average daily data for each of the meter points. And so the data comes in 2 parts. So you've got consumption data, and then we've got event data. And the important, or the thing here is, these represent individual meter error codes as generated by EDMI meters. Which does, as you can imagine, if you were to think about generalizing this, has a bit of an issue if you then want to connect to Siemens meters, because their codes won't be the same. So from that point of view, one of the pushbacks to the meter manufacturers is actually that we need to think about standardizing this. So we take the 2 streams of data. The first one, on the consumption data, we do a PCA analysis. And you can see here then, from the point of view of the stopping rule, we take the first 2 principal components, plot it up here into the biplot, and then measure the distance of each point from the center, and then do a rank ordering of the consumption data and the consumption meter points. From the point of view of the event data, we do a correspondence analysis, and then do exactly the same rank ordering based on distance from the center. And then we plot them as a joint rank. So this is the point with all of the different points of the data. And the important point here then is we then take this straight plot here of joint outlier rank, as we call it, and we do a density. So we look at the number of points within the different area. And you'll start to see a feature emerging. And you'll see this was 44,000 meters, of which we found 560 in this peak with a deviation from the background of more than 2 standard deviations. Now, I have to say that we went looking for theft. What we've actually done, and we've had a lot of conversations with British Gas recently about this, is we've actually found, a tool for detecting anomalies. And now anomalies can be a whole host of different things. It doesn't have to be just theft. It might be meter behavioural problems, so the meter's gone wrong. It may be customer anomalies. So from that point of view, when we did this the first time, we actually passed back some of the meter point numbers to the Revenue Protection Unit, and they went to look they actually did some physical visits. They said they hadn't actually found any theft, but they had found somebody who'd connected their gate to an electricity meter. It was the only thing that was connected to a meter point. So from the point of view of a consumption profile, they were massively anomalous. And because of the fact that effectively the meter had no consumption, huge spikes in consumption and drops, the meter itself used to also fire off a couple of events because of the rate of change. So there was so from that point of view, that's to the business unit. That's why have we got to this scenario where we've got a meter that's just supporting that. Another one was one where basically somebody had a battery, had a large sort of piece of equipment that was poorly connected and was just firing off events. Basically because of a massively noisy consumer that was causing large numbers of events within the meter. The profile of consumption wasn't that unusual because it was a fairly constant use, but because it was poorly connected, essentially the meter tails weren't well connected, it was causing a lot of events. So from that point of view, and this is actually now been patented, the joint outlier mechanism here, we're then going to look essentially in extending this story out beyond where we are now to actually look at anomalies in streaming information. So, creating new algorithms to cater for different and hitherto not well utilised data sources, and that's certainly the event data. So just to finish up, we of course have got this linking here. And what I would say is, of course, that if we think about many ways and discussions about how people have been talking about using meter information to look at how we can better inform our knowledge of the network and everything else, we actually then start falling down this chart here and actually say that the information that we're getting at each of these points, I would say in some ways gets less and less certain. So when we say that we want to use meters to actually inform network behaviour, and particularly when we're starting to talk about how we may utilise this information for demand response and things like that, that actually one of the crucial parts here is going to be information accuracy. From that point of view, really being able to highlight where there are poor quality information ending up within this stream is going to be more and more important the more we want to actually use the information for use cases above and beyond where it was originally designed. So I'd just like to thank, obviously, the guys that have actually worked on this, so Colin, Neil, Ramon, Piotr, Steph and Baz, and say thank you very much. Sorry I went on slightly long, and any questions?
So, I'm going to run questions until, let's do at least 10 minutes questions and see how we go. And if you're still hammering David, we'll keep it going for a little bit longer. So, first question, please. Could you, by the way, just to say that we are recording this, so if you have a problem with that, please let our administrator know. And could you give us your name and your affiliation?
My name is Miguel. I'm with the Pelican Corporation. And maybe one question then.
Yep.
Two ways. How accurate is this information then? That was sort of the conclusion. That's a crucial point, but and maybe the reason why I'm asking is how well is it are anomalies detected so that companies or people wanting to use this information can rely on it?
So how well are anomalies identified? I think the important point, and what we found from looking in this particular case with British Gas within Diet, is in some ways that the classification of what makes an anomaly is going to be most important. That may or may not be because of data inaccuracy. It might actually be it's just that the data is absolutely right, but the use case and therefore the generation of the data is done in a very, very odd way. So from that point of view, the guy whose gate is running on a meter, his meter is absolutely accurate. His meter is giving exactly what is expected. But from the point of view of if you were trying to include him in a population that may, for example, you want to utilise some form of demand response with because you were just looking at, oh, well, these are meter points within a domestic sector, you're going to get very different behaviour from him to other people. So from that point of view, one of the key parts, and I think, and a very important thing is, the meter data, both streams of it, is in some ways also supplemental, of course, to having detailed metadata. And this is detailed metadata also that you're not afraid, essentially, of being available to other participants within the stakeholder community. So, from the point of view of the meters, say, for example, at a domestic level, when you're trying to say, I want to do demand response, then having that information, so the property, where the property is, the type of property that it actually is, being available to the distribution network operator, for example, so they can understand the scope for demand response in that particular property, would be something that would be really useful. And from the point of view of other users, so particularly going back to the retail sector, of course, this was the most interesting point, was the companies themselves had very little understanding or visibility of the metadata that you would really expect a company to really understand. When I asked for numbers of floors in particular premises with one of the retailers we were working with, they couldn't tell us. I was like, what? You mean to...
Okay, I'm going to ration people to one question each, if I may,
yep.
Because the answers are very full, which is,
Sorry.
Which is exactly what, don't apologise, it's exactly what we want. So the gentleman with the check shirt. Sorry, the gentleman with the check shirt, I've just recognised you.
My name's Andrew Warren. I'm the chairman for the Energy Efficiency Federation. Thank you for that lecture. Actually, a couple of rather key points. You began by talking about the whole roll-up
yep.
of smart meters, 43 million across the country. We've got 8 million or so in already. One of the big concerns has to be, and it's not quite two questions, Bob.
1.5 questions.
The first one is, I can quite see that if British Gas has put a smart meter in, and which we begin with, and they have continued to have the particular customer tied to them, all well and good. But certainly it is perfectly possible for customers to do what ministers keep advising them to do, which is to switch to any other style, and suddenly find that their smart meter is
particularly dumb.
Smart.
Yes.
That's one point. The other point is it is equally possible to put in smart meters that comply, again, with what is currently required, which actually don't do even the most basic form of time switching. I mean, even the old invoices around here, who can remember Economy 7? They used to be.
I still have Economy 10.
Well, there you go. But yeah, that was the 7 hours in the middle of the night in which you got a lower rate, which people did understand. There are still some around doing. Now, that's being knocked out by installers, companies who are mandated to do this, who choose to follow what is the agreed party line. So I begin to wonder, do we just ignore the 8 million that are in now and hope to God that they can agree to put in something which isn't quite as old-fashioned as the meters that are currently being put in?
So from the point of view of the meters that have been rolled out as it is at the moment, I think the interesting part from talking to the meter operators is they see a portion of the population that maybe started off with a particular retailer. They see a very large amount of transitioning both in and out. So I was stunned when we were talking to British Gas when we said, well, we seem to see a very large number of meters dropping out from the thing. And they said, well, quantify that, and I did, but I won't say it here. And they said, oh no, that's sort of expected. That's what we are expecting. I think one of the points though is is in some ways the idea of utilising all of the information that's available actually allows people, or the retailers or the meter point operators or even the smart meter manufacturers, if they're involved in the data chain, actually to design and sell value add services. So from that point of view, utilising the information that they've got better. So for example, you can see from the EDMI MDS type point in the data chain that if they're able to sell to British Gas a better and more efficient way of quickly detecting anomalies, that then means that British Gas are able to interact on a better way with their customers, i.e. they don't send the inspectors around on a regular basis, which generally is not going to make them the most well-loved people in the world, then that's of benefit to them. When it comes to the major rollout, I suppose I'd say the really interesting point is going to be, we had sort of a few hundred out of 44,000 which are in that anomalous peak. From that point of view, when that becomes sort of tens of millions in the background, what that anomalous peak becomes, that's a very large number of meters. Because it's likely to stay the same. There's no reason really that proportion of the population is going to change. You're not going to get 200 out, a few hundred out of 50 million. So that from that point of view, it's going to start, from that point of view, it's going to start costing. I think an interesting one would be when people switch, what are they expecting to get as the value add service from doing that? I think that in the end, you're going to see a lower rate of switching once we're into a smart meter if we don't have fully standardised meters across all of their data streams.
But you'll accept the fact that ministers actually spend their time suggesting that people who should switch.
Oh yeah, absolutely, yeah.
Somewhat undermining the point
sorry.
Thank you for moving the discussion on so effectively. I'd like to bring in Paul Roosevelt.
Paul Roosevelt, Professor at the Energy Institute. I was interested in the comment that you made around the time of day tariffs, and I think you said that the aggregator who provided you with the data had spotted the opportunity to provide a service which was to advise all the winners that they could win. Of course, the reason that a company would put in a time of day tariff would be to encourage a change in the pattern of use. And what would result from that service would be no change in the pattern of use and the energy company losing money.
Well, so two things from that. First of all, of course, the take up of real-time tariffs are very small, and what we were able to show them, and what we showed them, and actually what they haven't yet to take up fully, is the idea of that most of their consumers are actually on fixed price tariffs and actually could then migrate. But the interesting point is when they migrate, because of course one of the bits that energy aggregators do is buy energy futures, which allows them to buy energy of course at different times. So from their point of view, as efficient utilisers of the market, they would be able to say, well, okay, we're going to move people into time of use tariffs. And as an energy aggregator, I'm therefore going to be able to make better energy forecast decisions about when I'm buying energy at which particular time of day. So from that point of view, that's the sort of the full expectation of how they would see this being of benefit.
I'm sure it's for business, it just doesn't achieve what the energy company wants.
Oh, no.
Okay.
Thank you very much. My name's Eugene. I'm a recent alumni from the Energy Institute. I was really fascinated by what you said about the investigation into energy theft, and it seems as though you've found something that can identify anomalies. But what about the original problem of energy theft? Is there a way to build prediction models that will allow you to, having identified those households or businesses who are stealing energy, to then find others who are also stealing energy?
Yes, so one of the really interesting parts actually is how energy theft is defined. So energy theft, as it currently stands by the RPU, is defined as physical tampering with a meter. Now, one of the things in the original 200 theft cases that they actually showed me was that there were a non-trivial sort of, 170 or so people that were doing physical interruptions or physical tampering with the meter. But there was an interesting 30 that were doing essentially electronic tampering with the meter. And from that point of view, that becomes a much more difficult thing for the RPU and people like that to actually find, unless people are very careless, because of course, if you electronically fiddle with a meter and then you take it away and inspector comes round, your meter looks completely normal and nobody notices. Inspectors are very good at spotting pinholes from needles into the backs of cables and things like that. Not so good at defining whether or not somebody's stuck into the fibre connector. So from that point of view, our aim actually is, and we've got EDMI looking at this from the point of view of what are the usual event case outputs for theft cases when it comes to electronic meter interference, and where at the moment we look at event data from single event occurrence frequencies. So how many times in the time period a particular event went off. What we've actually got now and we're testing is, well, how many times has a particular sequence gone off? So how many times has event A been followed by event B? And if that happens and it's followed by event C and it occurs within a short time period, well, we know that's a good case because that's almost certainly the engineer. But if we know that event A and B happen very quickly and event C didn't happen for weeks, actually know that's something that, that actually is likely to be somebody actually fiddling with the meter. But they've put the meter back to the state when externally visible when it's supposed to be in.
I'd just like to comment here.
Yep.
You're obviously an astronomer, an ex-astronomer. It just seems to me that one of the lessons of all of this is that whenever you have a new data source, you find new phenomena.
Oh, yeah.
And I'm just thinking of pulsars.
Yes.
Which has been in the news this week.
Yes.
So we shouldn't be surprised that when we get a new source of data, and much richer data, we find all sorts of amazing stuff that we didn't expect to find. Can I take the...
Hi.
I confess I can't describe the colour of your jumper, but...
Deep red.
Deep red, yeah.
Okay.
I do an MSc in urban regeneration at the faculty, and I wanted to ask a social question about how easy is it to change the behaviour of the retailers when they're only open in a certain amount of time, and also they've been doing this for some period of time, so how far can they keep on making improvements?
So, well, I suppose I'd say the most obvious improvement that's been made by some retailers in energy consumption, and it's been shown to have a fairly sizable effect, of course, is doors on fridges. So the British Retail Consortium, essentially, that was a recommendation, and you'll see if you go in a co-op now, I think every co-op has said that they will have doors on fridges. I know co-op is my local shop, that's how I know. And from that point of view, there are changes that they can do. So from one of the bits that's really interesting is still the position of hot air curtains within buildings very close to high frequency opening doors. That actually have very little effect when you actually get in from the people that are in the store for long periods in their actual levels of comfort. It allows people to walk in, feel very warm, and then they feel warm as they carry on walking around the shop. But from that point of view, there are little tiny improvements. Think about British Cycling. There are marginal gains to be had from a whole host of different things. And the really interesting point with the retail sector, and this is where the legal instruments, the green lease and the MOUs are very interesting, because of course the vast majority of property within the retail sector is leased, then it requires for anything above small changes in displays and stuff like that, it requires an interaction between the tenant and landlord. So from that point of view, things like Argos store, so there was, I think it was Argos stores, there's a large number of them that had the very high level, because they're warehouses essentially, those sort of hot bar heaters that were...
Radiant heaters.
Yes, so...
Like the sun, but square.
Yeah.
So I'm trying to appeal to the astronomer.
And from that point of view, they were then phased out, but they required an interaction with the landlords of those properties because there were structural changes in the building to actually change to different types of heating. So from that point of view, there are lots of small changes, and one of the things, and this comes back to the return on investment, being able to quantify the benefit that even a small change has made. is very, very important. You know, so LED lighting schemes, for example, is the big favourite, of course, within the retail
Right,
sector.
I'm going to take, if I take 2 more questions, will you lynch me? Because I'm keeping you away from refreshments. Was that a nod at the back there? Okay. Mike, go for it.
Mike Bell from UCL-Energy Institute here. Very quick comment first on the smart meter functionality point which was raised earlier. It's my understanding that most of the meters which are being installed at the moment will be SMETS 1 meters. The ones that are going to be coming in from now on should mainly be SMETS 2 meters. But by the middle of next year, those SMETS 1 meters are meant to be brought up to date to the SMETS 2 level and allow that full switching functionality. So in theory, most of those, some of them weren't SMETS 1, but most of them should actually have that full functionality to switch. That's anyway.
That's really useful
kind of
clarification. Thank you.
My question for you was that, bearing in mind that you can recognise this potential theft, but also anomalous events.
Yep.
One of the concerns that's often raised about smart metering is that it gives companies the opportunity to sort of pry into people's lives. And I wonder where you would draw a line between the legitimate desire to sort of recognise these problems and prevent theft, which everyone would want, and just the power it gives you to, well, potentially send out operatives to go and actually find someone who's just having a really good time using the
Well, you know, we don't really want to interrupt people having a really good time. So one of the things I say is actually, because from the consumption point of view, our plan of utilising average daily consumption was the point of actually saying, well, you know, we don't want to be trying to use half-hourly consumption points in this, because then one of the things we found essentially is, in many cases, they're fairly uniform over days. So from that point of view, it's using extra days, using extra compute power for very little actual gain of the information that you're trying to glean. The other one, because it's a joint rank, it actually is therefore an occurrence of strange beta behaviour from the consumption and strange event data within the meter. So from that point of view, if somebody's behaviour is causing both of those, you know, that's something that from our point of view we say, well, okay, you know, I think that's a fairly legitimate, and as it is only a fairly small number, but a very large deviation from the background, that sort of allows, you know, from our point of view, we're like, well, you know, that's a fairly legitimate reason to say, actually, let's go and have a look at this, or essentially allow us to look more into the data. So from that, it would be, you know, the first step wouldn't be to send around the heavies, as some people think of them, but actually to say, well, okay, let's just look in the data more. What's causing this? And some of these, you know, they may be well known. You know, as soon as you actually start looking in detail at the consumption, for example, we didn't send around the guys to work out the guy who had his gate connected. It was like, okay, well, you can see here that you get spikes of consumption at various times which look like somebody coming and going, and then somebody else went and said, oh, okay, we know that meter, that's this. So from that point of view, it's a case of, by trying to use as little data as we can, we hope to get around the privacy issue. It was something within the project that was very, very sort of well understood very early on, because we didn't release any sort of public statement about the project for quite a long time through it, because of the sensitivity for people around smart metering. And, you know, from that point of view, we didn't want to suddenly scare people with, oh, well, you know, we're going to find everyone and send the guys round. From the point of view, actually, of the interesting point of the metering, so working with EDMI has been an interesting one, because from their point of view, their SMETS 2 and their SMETS 1 meters are pretty much exactly the same, with essentially firmware updates. So from their point of view, that's one of the things that they said, oh, it's not a problem for us, that sort of thing. But the more interesting point, of course, is the smart meter rollout is supposed to go through and involve the DCC. Now, what I want to see, you know, from my point of view, is I would really want to see that the DCC is actually the funnel for all streams of data that come out of smart meters. It would make an awful lot more sense if basically everything of the consumption and the non-consumption went through the DCC, and then they were the people that handle when somebody changes supplier and changes meter manufacturer, that effectively they're the people that are doing the translation of non-standard data to standard data in non-consumption information.
Can we take one more question, and then I'm going to bring it to a close, please. Could you say who you are?
Yes, Noah Conge from Bureau Happold Engineering Energy team. So we work on sort of new cities, so we've got an opportunity to sort of roll out smart meters that are going to have the right communication protocols, etc. So you mentioned that for domestic properties, the price signals might not work because it's too much information to process. So in terms of managing, so the idea of the energy infrastructure we look at for new cities is reducing the peak demand and therefore the cost of the infrastructure you have to put in. So in terms of understanding that opportunity on the domestic side, do you think there's more of an opportunity to look at, say, automatic controls of equipment in the homes rather than using price signals as a way to behaviour?
I think from the point of view of societal uptake, then I would look very closely at the two use cases that are fairly well known around this of Northern Ireland. So Northern Ireland Energy had a fairly well known sort of time of use type tariff. And actually the French, so the EDF had a scheme as well where they could effectively pre-warn people about essentially what they termed as red days, which were days where they were predicting very high consumption, and therefore they sort of pre-warned consumers. The other one, as the gentleman at the back also mentioned, as we have had a long history of being able to shift consumption with things like Economy 7. I was an Economy 10 user until recently. I am SSE's only off-peak BX consumer at the moment. I have a time clock which basically says that I get electricity on one of my meters in a certain point because I'm an electric-only household. But the interesting point actually is I would start simple and move from there. So, Economy 7, Economy 10, red days, the Northern Ireland thing, these were very simple, but they had the desired effect. People used them in a way that they were designed. I think one of the problems when you start talking about automation and things like that is, and I mentioned her twice already, but these sort of things have a danger of not passing the mother test. When I tell my mum that she shouldn't put stuff on, and when she asks how much, why not, and I say it's going to cost you more, and she says 20, I say 20 pence, and she says I don't care, that's a problem. So unless you're going to make the pricing...
I don't think that's a problem.
They would trust...
Your mother is entirely happy.
This is the point. No, but it's what it actually is my mother is actually entirely autonomous with a very large amount of the population. So if a very large amount of the population completely ignores all of the information they're getting from this extremely expensive infrastructure that we've installed that's consuming a very large amount of extra energy, then we've made a problem for ourselves for completely no reason whatsoever. So what I would say is start simple, engage people, and then give people the opportunities and show them how they can actually make further savings by utilising maybe more complex tariffs, but make sure that it's then presented to them in a way where it showcases the benefits.
I think that's a really interesting place to stop. So I'd like to thank David for an absolutely excellent presentation and a wonderful Q&A session. So thank you very much, David.
Thank you. Thank you.